Hey, 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 everybody. Bum, 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 bum. But that was terrible opening music, I'm gonna be honest with you. It's not good. I apologize. The budget for the show right now isn't too large. So doing the best with what I got. Math. My arch nemesis, math. Completed a bunch of stuff in the last stream, some simple things. And now we're getting into some stuff that's very scary for me. Exponents. Exponents basic. Then there's regular exponents, apparently. So you have, it's like, there's like exponents and exponents basic. I guess that's like Coke and like Diet Coke. Maybe this is Coke Zero. It doesn't have all that extra exponent calories in it. And then there's variable expressions with exponents. This is going to be bad. Like I did okay on the last stream, but this is not going to end well. So let's jump right into it, shall we? Boop. Okay, so exponents. I feel like I remember exponents. So I I don't think I need to do the training because exponents is just like you're just multiplying the results of a multiplication by the number, I think. So this is basically 0 times 0, right? 0 to the second. I think they call them powers as well. So that's just 0. Pretty sure. Anything times 0 is 0. Hey, how about that? Okay. So, next question. 8, so this would be 18. This would be 8 times 8. Oh gosh, I don't, this is the thing, is that I don't have strong multiplication tables in my head. So 8 times 8 is um I don't know. I might just get a calculator out for this. I don't care if it's cheating. 60, is that 64? It's not 64, is it? It can't be. Oh, whoa. How did I legit honestly don't know how I knew that. Honestly, no clue. Okay. Next question. So this is where it gets uh like super scary for me, right? Because this is I'm pretty sure it's 2, so it's 2 times 2 times 2 times 2 times 2, but I think you're supposed to multiply the result of the, so um 2 times 2 is 4, right? And then times 2 times 2 is 4. Then times 2 is 8. And then times 2 is 16. And then times 2 is 32. 16 times 2 is 32, right? So I think 2 to the 5th power is 32. I think. Oh my gosh. Oh my goodness. So yeah, so you're multiplying the result of the as you go. So this is it's I wish I had like a, oh my gosh, I have a thing where I can do, so this is, so 2 to the 5 is basically 2 times 2 times, I don't have like a drawing pad, so it's, I'm doing this with a mouse, times 2 times, so 2 times 2 times 2 times 2 times 2, right? And so the way that worked out is 2 times 2 is 4, right? And then you're doing it times 2 again, and then that's when we got to the 8, and then that's times 2, and that's how we got to the 16, and then that's times 2, which was how we got to 32. Bam. There's your basic exponents. Right there. So that should be fairly... It even has a little... Oh, cool. You can just select... That's neat. Okay. So I can... How do I hide the squigglies? Match each expression to its exponential form. So this is 3 to the 4. So this is the exponential form. This would be the results. So that's not what we're looking for. And this is just wrong. This is just because you always multiply by whatever this is called. I could probably watch the video and know what it's called. Yeah, so 3 times 3 times 3 times 3. That is 3 to the 4th power. Oh, I should actually select something. Oh, I need to actually... What? Match each expression to its exponential form. Oh, okay. So that, and then 3... Is that right? This doesn't seem right. I don't know why this is here. This is kind of throwing me off a little bit. Yeah, it's 4 to the 3rd power, it's 3 to the 4th power. So this has to be, I don't know why this 27 is here. I don't. Well, I guess it's because it's the result. Right, 3 times 3 is 6 times 3. I don't know. I have no idea. I got it right. Let's go with that. Write an expression equal to 7 to the 3rd power. So that'd be 7 times 7 times 7. 7 to the 3rd power. Bam! 2 more. Oh, I didn't get this one. Did I got that one wrong, I guess? I'm not happy about that. It tricked me. I didn't know I was supposed to drag and drop stuff. Okay, write an expression using an exponent that is equivalent to 6 times 6 times 6 times 6 times 6. So there's 1, 2, 3, 4, 5 6s. So it'd be 6 to the 5th. All right. Yeah. I have leveled up to familiar. I didn't get this thing because of this stupid question here. Oh no, wait. It's just there's more. There's more. I think 1 to any power is just 1. Right. Yeah. So I got 6 out of 7 correct, which I'm not exactly happy about, but I'll take it because it's gonna get harder from here. Because now we're no more diet exponents, no more exponent 0. This is the real exponents here. I need 5 out of 7 questions to move on. Oh, these are practice. I guess. Oh, this is just practice stuff. Complete the inequality. Oh, snap. Oh, snap. Okay. So 5 to the 2nd power, that's 10. 2 to the 5th power, that's 2 times 2 is 4, times 2 is 8, times 2 is 6. So this is much greater than this one. They try to trick you because there's 5 here, right? It looks bigger. Tricky. Why are you so tricky, Con? Trying to be such a trickster. Make me look bad on Twitch. I'm making me look bad on Twitch. It's okay. Okay, determine whether each equation is true or false. Oh, whoops, I accidentally opened. Oh gosh. large program is opening now because I accidentally clicked it. Why? Why did I do that? Why now? Stop. No. Go away. Go away. Stop loading plugins and stuff. It's fine. It's gonna be okay. All right. So determine whether the oh gosh, it popped up again. Determine whether the question is true or false. 2 to the 16th is equal to 6 to the second power. So 2 times 2 is 4. This is the same. No, they're not. Wait, are they? What if they are? I'm pretty sure this is true, because I think 10 to the third, you just need to 10 times 10 is 100, right? Times 10 is 1,000. So 10 times 10 times 10 is going to be 1,000. And then there's probably a trick here. There's probably some trick that I'm just not aware of, that if I watch the video, I would know. But I'm too stubborn to watch the video. 2 times 2 is 4. Didn't I just do this earlier? Isn't this 64? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So that's 64. And then I think 6 times 6 is 36. So they're not equivalent. So 4 times 4 is 12. And then 12 times 4 is, oh, there's some trick multiplying against 12 that I don't remember. I don't remember it, but I don't think that this is equivalent, because 8 times 8 is, I don't think so. I should really get out a calculator and just verify it. Oh, not quite. Not quite. This is true, isn't it? Yeah. Okay. So 4 to the third power is equal to 8 to the second power. And I'm sure that there's some sort of rule that I could have used to quickly check that. All right. Next question. Oh, crap. So now we're getting into decimals here. So 0.2, I don't think it really changes too much. 0.2 times 0.2 is, what is 0.2 times 0.2? 0.2 times 0.2 is 0.4, I guess. Times 0.2 is 0.8? I feel like the answer here is just 0.16. I think with stuff like this, you could just move the decimal over and treat them as whole numbers and then convert it back. Pretty sure. I have a feeling. Let's see. No! What did I do wrong? Might need to watch a video on this. 0.04. Oh, Elite's trying to help me out. Elite, you gotta help me out in the Twitch chat. Are you watching? Elite's helping me out. 0.2 times 0.2 is 0.04. Why is it 0.04? Hold on, I'm just checking. I really should just use a calculator, because I don't have the ability to just check. I just need to check myself. 0.2 times 0.2. Yeah, elite is correct. How does that work? 0.2 times 0.2 is 0.04. We're gonna need him to explain that to me. Elite's gonna explain that to me later. Okay. 0.02. Wow. Okay, so I really did not understand this whole multiplication here, because this goes very, very deep. So times 0.2. Is it really? I want to watch the video on it. Exponents of decimals. We're gonna watch it. Just to... Okay. Perfect example. I already tried. I failed, dude. Right. Right. That's what I figured. Oh. Oh. Oh, I totally forgot about this. Okay. Oh gosh, what just happened? Somebody did something. Hey, Elite with the follow. Thanks, buddy. Right. It's 881. Right. Okay. Got it. Do the decimal multiplication. Okay, beautiful. Beautiful. Thank you, con person. So okay. So just to write all of this out, how do I go back? I want to go back here, please. Can we Okay, so anyway, this is 0.2 times 0.2 times 0.2 times 0.2. All right, and as they said, so 2 times 2 is 4. And so we have 1, 2, right? So we need to move it 2 places. So it would be 0.04, right? And then that's times 2, or 0.2. So that'd be 8. And then it's 1, 2, 3 places, right? I hope I'm doing this right. So 0.128, right? And then that is times 2. So That's 16. And then it's 1, 2, 3, 4. So it's 1, 2, 3, 4. So then we arrive at 0.00016. Because it's decimal multiplication. And I clearly forgot my decimal multiplication. What? Elite, what did I do wrong? What have I done wrong here? Where's the Twitch chat? Oh, there it is. Elite says that's correct. But it says I'm wrong. What did I do wrong? Let me check the calculator. The calculator says that that's right. Khan, what are you doing to me, man? What are you doing? Do I need to put the 0 in front of it? That would be so silly if I needed to put the 0. What? Why is it 0, 0? Oh, because the 1, 2, 3, 4. Shouldn't it be 1, 2, 3, 4? Where did I go wrong there? Does the total need to be 4 away? 1, 2, 3. That's probably what it is. Dang it. Okay. So it needs to be 4 decimal places from the end. Thanks, kids. Okay. We're going to move on from that one. Pretend that whole thing. Yeah, total needs to be 4. Thank you, Elite. But if I click the get hint button, then I don't get any points. So I would rather, but I'm probably not going to get any points from screwing all these up. Okay, so this is they're trying to trick me here. Okay, right. Your answer should be a simplified proper fraction, like 3/5. Oh crap. Okay, but maybe I can just like convert this first and then convert it back to do the math, I'm guessing. So this would be like 0.5 times 0.5. Can I do that? I'm pretty sure I can do that. 0.5 times 0.5, right? So 0.5 times 0.5 is going to be 0.01. If I'm looking for confirmation. Elite says I can. Elite says it's possible. So we're going to do it. So this is times 0.5. Right. Which is I have no idea what that is. What is I'm really bad with decimals. I'm just realizing no wonder I'm not an accountant. Because I would just be screwing up. This is why I pay somebody to do my taxes, because I just can't do the decimal. That's 0.5. Let me just get an answer. Okay, that makes sense. So it's just 1 times 5, and then it's the same decimal multiplication, right? So 1 times 5 is 5. And then it's 1, 2, 3 places. So 0.005. And then that's times 5. Right? So so 5 times 5 is 10. And then this is 1, 2, 3, 4 places. So it's be 1, 2, 3, 4. Right? No. Elite's like, no. That is not it. Let me do another verification over here. Just a quick check. 5 times 0.5. Oh gosh. Oh my gosh. Oh, right. Stupid. Did I say 5 times 5 is 10? It's still early here. Do I get a pass for it being a bit early here? And I shouldn't be trying to do algebra in the morning. Okay. Obviously 5 times 5 is not 10. That's ridiculous. That's totally 5 times 5 is 25. What's up, Zeg? Yeah. So, how do let's erase this. Let's get rid of this. That's the thing about streaming, is that if you say something stupid, it's there forever. And forever and ever, there's going to be me saying 5 times 5 is 10. There's nothing I can do about it. Okay, so 5 times 5 is 25, right? So 1, 2, 3, 4. But I got a different result when I actually did the multiplication here. Oh gosh, I did all of the math wrong because for some reason I had 5 plus 5 in my head. Damn it. Okay. We're going to start over. We're just going to start. This is the simplest thing. Let's try this again. We'll do it in red. Okay. Obviously 5 times 5 is 25. So as chat has pointed out, started off wrong. Instead of doing decimals, do fractions. How is that easier? 1/16. Multiplying fractions is way scarier though. You just multiply the denominators. Oh, so if I just did, okay, hold on. I'm getting schooled by the kids here, trying to put me on. So if I just did 1/2 times 1/2 times 1/2 times 1/2. You're saying that I can just multiply the denominators, and then that will give me, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So then that gives me 1/16 is what you're trying to say. Over there, like that. So that's the answer, right? Because they wanted in a simplified. I did not even. My goodness, this is why I need y'all. I don't know how I'm gonna get through any of this algebra stuff on my own. Okay. So 1/16, because you can just take the okay, so you're multiplying fractions, you just multiply the denominators. I guess that's only if the what do you call, what's the top one? There's the denominator and then there's the, is that the nominator? Let's just get the answer here. Woo! Okay, cool. See, I skipped all of the fundamental stuff and went straight to the algebra, and now I don't remember all the tricks, and I'm getting caught up here. The numerator, of course, the numerator. Right. So that trick only works when all of the numerators are the same. Cool. Very good. Thanks, y'all. Okay, complete the inequality with blah, 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 or blah, blah, blah. So this is 4 times 4, which is 12, times 4, which is 48. And then 6 times 6 is 36. So very clearly, let's get rid of this. The 4 to the third power is greater. 2R. Determine whether each equation is true or false. I'm getting pinged on the Discord. Oh, okay. There we go. A couple people pinging me. But I think they're all in the Twitch chat now. Twitch chat is better, because then you can laugh at me and it'll show up on the screen. What did I say it wrong again? 4 times 4 is 16. Of course, it's not 12. Of course. I should go get some coffee. All right. 3 to the second power is not 2 times 2 times 2. I dub thee false. And then 5 to the third power is not 15. Because it would be 5 times 5, which I now remember is 25 and not 10. And then it would be times 5 again, which would be 125 and not 15. So you are false. An 8 to the first power is 8 times 8, right? Or is that just 8 times? I kind of feel like if it's 8 to the first power, does that mean it's just 8 times itself? Yeah, so it's 8 times 8, which is not going to be equal to. So these are all false. Mr. Khan, it's kind of funny because his name is, it's the Khan Academy, and he's trying to con me here with all these sneaky questions. Okay, here we go. More decimal mathifications over here. So I'm going to so this is just 0.9 times 0.9, right? Which is 9 times 9 is 81. Is 9 times 9 81? 9 times 9 has got to be 81. 9 times 9 is 81. Okay, I got something right. Yeah, I don't know. I don't know how I'm getting the right answers and explaining this totally wrong. Nobody should use this video to learn at all. Like, really, it should just be entertainment purposes of laughing at me struggling through math, basic math. This is not an educational video whatsoever. So this would be 81, and then it's 2 decimal places, right? So, and then it's 2 total decimal places. So I guess it's just 1. No, that's not right. That's 0.9 times 0.9 is, let me just, it is. Yeah, it is. I don't know why that seems wrong. 0.9 times 0.9 is 0.81 for some reason. How does math even work? Like, I legit don't understand how math mathificates. There's probably a way to, like, write that out in long form so that it makes sense. But I'm familiar. I got enough to be familiar. 5 out of 7, that was the limit to move up. Thanks, y'all, for all the help with this one. I learned a bunch of concepts that I totally forgot about, or maybe I just never learned them. I'm not really sure. Okay, so now we're on to variable expressions with exponents, which is probably where I could just, like, watch all of this stuff and learn, couldn't I? They have all these little intro to exponents, but it's more fun watching me fail. So we're gonna do this. We're gonna practice. Use x equals 1 to identify the value of each expression. Okay, so that's 9 to the first power, which is 9, right? No, it's not. It is not. What is 9? Is when you're doing the powers, is it like if it's... It is. Elite's like, yes, it is, you fool! You fool! Right, okay, so if it's 9 to the first power, it's like 9 times 1? Is that what you're trying to tell me? Rather than it's just 9. It's like it's not 9 times. Oh, because 9 to it's 9 itself. Got it. So this is true. So 9 to the first power is 9. And then 3 to the first power is 3. And then 1 to the third power is going to be 1, because 1 times anything is going to be 1, right? Pretty sure. 1 times 1 times 1 is definitely 1. I know that for sure. I know that. We got it. We're getting through. Okay, Khan, I'm going to find you. I'm pretty sure when you get to the end of this stuff, Khan is just there waiting for you, and you have to like bare knuckle box Khan to get your Master Khan degree. Or at least I hope. I'm going to be disappointed if we get to the end of this and there's no bare knuckle boxing with Mr. Khan. Okay, evaluate the expression 5x minus 3x for x is equal to 2. Okay, so that means that we're at 5 to the second power minus 3 to the second power, right? And so this is 5 times 5, which of course is not 10. It's definitely 25. Depending on how much coffee you've had in the morning. And then this is 3 times 3, which is definitely not 6. It's definitely 9. Right? And then, so then we have 25 minus 9, which is 16, 16, 16, 16, 16, 25 minus 9 is 16. How did I do that? I have no idea how I did that. I did it with math. Don't tell anybody. And a calculator. All right, so 16. Bam. Dunskies. So now it's oh my goodness, now they're trying to throw some very fancy stuff our way. Now there's an X and a Y, and they equal different things. So this is going to be 3 to the third power plus, that is a gigantic power over there. I mean, that's, imagine that like the power is a hat, and this hat is like almost the size of the person that the hat is on. That is ridiculous. That is a superpower right there. That's not even a regular power. So 3, okay, and then Y is 4. So this is 4 to the third. So 3 times 3 is 6. Times 3 is 18. 18 is 12. Pretty sure it's 18. And then 4 times 4 is not 12. It's 16. Times 3, which is, I don't know. I have no idea. Let's get an answer here. Times 4. It's 64. I should have known that. 3 times 3 times 3 is 27. How did I get to 18? Oh, because oh gosh. Oh my goodness. I'm so glad I got the crew here to help me out. Because this is... gosh, I should not be doing this in the morning. Yeah, you're right. How did I get 18? How did I even... Hold on. We need to stop and like allow my brain to understand how it even said something so stupid. 3 times 3 is 6. Times 3... Oh, because I was doing... Okay. I think I was just doing addition again. My brain just decides to change the operators. So this is a very stupid thing to say. And we're just going to squiggly it out. And hopefully... And maybe we'll even... I don't know. We'll put a smiley face there. Bloop. So nobody will know that it was a horrifically embarrassed mistake. They'll just be like, oh, he just decided to draw a picture. And we'll give him some hair. Some red hair. There we go. There we go, buddy. Okay. Happy mistakes, right? Okay. So, but of course my answer was 27. Then we'll put the plus there. So it's 4 times 4, which is 16, times 4. 4 times 4, it's 16. Times 4 is 64, as I said before. Bloop. Okay, and then so it's 27 plus 64, which is 91. 91! Thanks, y'all. Beautiful. Beautiful. Use x is equal to 2 to identify the value of each expression. So here we're doing some more mathification. And x is 2. So this is 2 to the 5th power. So that's, what's the easiest one? 8 to, okay. 8 times 8 is 64, right? So 8 to the 2nd power has got to be, oh, whoops. It's got to be 64. Right? And then 2 to the 5th and 2 to the 4th. So obviously, I mean, just, you know, using deductive reasoning and not mathification, you can imagine that 2 to the 4th is going to be smaller than 2 to the 5th. So I think that this is in the correct order here. Yeah! Variable expressions with exponents. I got 330 energy points. Booyah! All right. So, that was embarrassing. What is next? Oh gosh, square roots. Okay, I think we can knock out the square roots, and then that will be the stream for the day. Let me just remind. I just want to be reminded here. Let me get an intro to square roots. Right. The radical Radical dude. Yeah, what is that about? The radical. I'll be the judge of that, okay? It's just 9. Oh no. Right. What times itself is equal to 9? Got it. Right. I'm looking. I'm looking. Okay. Okay. Right. I don't know. Oh, right. Let's do it again just to make sure that I had 25. Okay. I think I know this. It's got to be 5. Please tell me it's 5. Oh, I did it. Oh my gosh. Okay. Okay. All right, folks. I got this. I got this. Yeah, we're about to square it all. Oh, you can't see or hear the video? Oh man, I bet Khan Academy has some sort of thing that prevents. But that's weird that you couldn't see or hear the video. Let me see if it shows up on the. Oh, that's weird. Because it shows up on the OBS thing. Oh, now you can see it. Okay. Sorry that it wasn't visible there before. All right. Let's get through some squared roots. This is okay. So what is the square root of 49, right? It's something times itself is equal to 49. How am I supposed to just figure that out? Do you just... Zeg, help me! What do I do? Okay. Well, it's got to be times itself, right? So if we just divide, what number times itself is equal to 49? Well, 6 times 6 is 36, right? So if we go up 1, I bet 7 times 7 is 49. I bet you. See, this is where having those math tables is super important. Yeah, 7 times 7 is 49. The square root of 49 is 7. Beautiful. And as I just said, 6 times 6 is 36. So the square root is going to be 6. And 121. Is that... Oof, I have a feeling it's 12. No, it's not. What is 12 times 12? It's a lot more. 12 times 12 is 144. So it's probably 11. Yeah, it's 11. It was 11. I was close. Square root of 121 is 11. And the square root of 9 is going to be 3. It's 3, right? 3 times 3 is 9. Duh. Square root of 100. It's duh. It's 10. Square root of 100 is 10. And we did this one before. Square root of 25 is 25. Woo! Familiar. Okay. And then I have one more. 64. That was 8, right? Pretty sure that was 8. Yeah. Okay. All right. So, having strong multiplication tables in your head is definitely important to success in stuff like this. I managed to get by it. Simplify square roots. Okay. Let's see what that's all about. How long is this stream? How long is this stream so far? Okay, cool. So we can make this a solid hour. All right, 4 questions. What are we doing here? Remove all perfect squares from inside the square root. And they even give me a calculator for this one, which makes me feel bad about using a calculator for all the other ones. But let's look at simplifying square roots, because I'm not exactly sure. And I'll try to make sure that y'all can see the video this time. Yeah, it doesn't seem like they have something to make it so that you can't capture. Yeah, sorry. You're not going to be able to see it because they have some anti-screen recording software or something. Okay, so he has 5 in square root 117. What? How did he just simplifying square roots? I'm going to read it. I'm going to read the thing here. Roots are nice, but we prefer dealing with regular numbers as much as possible. So for example, instead of the square root of 4, we prefer dealing with 2. What about roots that aren't equal to an integer, like square root of 20? Still, we can write 20 as 4.5 or 4, I don't know why it says 4.5, but the point is like in the middle. And then use known properties to write square of 4 times 5 as 4.5, which is 2 to the 5th. We simplified the square of 20. I don't think he explained that really that well. The point in the middle is times. Okay. What? Uh-huh. What? What is he talking about? Oh, you have to use the point. You can't use the X? Ah, that's interesting. Yo, he's doing a bunch of stuff on here that just straight up lost me. Okay, he's gonna do another example. Maybe this will, because it does not look like what I was given here. Remove all perfect squares from inside the square root. What does that even mean? I'm gonna have to use a hint. Oh, I don't want to use a hint. Okay. So 1/2. Let's factor 18. 18 is equal to 3 times 3 times 2, which is equal to 3 squared times 2. Okay, like I get that. Zeg, what am I? Uh-oh. Zeg was having trouble with it as well. Remove all the perfect squares from inside. I don't know what it means by remove all the perfect squares from inside. Well, I guess that's maybe that's what it means is that this is the perfect square. So in order to arrive at the square root of 18, you need uh 3 to the second power times 2. So it's 3. Ah, okay. Oh gosh, golly. Okay. Got it. Got it. So within the square root of 18, this is I actually do remember this from a long time ago. But I don't know how to like do it all out by hand like they did here. So right, so 3 times 3 times 2, and then this is a perfect square, right? But in order to get to the square root, you still need to multiply by 2. That's what Zeg's like, yeah, okay. So if they're asking me to remove all the perfect squares, does that mean that they just want me to write the perfect square? So like this is 3 to the second, right? 3 to the second. Or do I have to do the times 2 as it says here? No. I guess maybe it just wants the perfect square. No? Give me another hint. Oh, okay. Okay, got it. I didn't do it the full way. Okay. Now we can take the perfect square out of the square root. So this is 3. So the square root of 18 is equal to 3 to the second power times 2. And then but why? Oh, because the square of 3 to the second power. So okay. So you're doing the square root of this, so you can remove that. Okay. So that's why it's okay. That's interesting. I wonder if I'm going to be able to do this on my own. So it's 3 square 2. Right? Well, yeah, of course. It literally told me the answer. But I'm still not sure how they arrived at getting um all of those values out of it. Like, I need to see again. Like, how did he do the multiplication to... You probably can't hear it, but I'm watching. Okay. So they're doing prime factorization. Okay, so they did some neat little math trick here. So it is divisible by 2. So 180 divided by 2 is I don't know, 180 divided by 2 is 90. Yeah, but why was that important? I need to see an example. Oh gosh. My goal is to find, as I was saying, my goal is to find the largest perfect square that you can divide 180 by. So right, so square root of 180. Oh gosh. This video example that they have here, it shows how to do it if it's not 17, 3 times 39. So here's the way that they're doing it in this video, right? They have 180. They have, let me just get the black, right? 180. Okay. And then what they're doing, so 2, they're doing this. They're doing 2 times 90 is 180, right? And then going down further, times 2 and 45. Right. And then we can't divide 45 by 2 anymore because that gets us a decimal. So let me look at the video. What do they do? What do they do when they can't divide? Let's go back over here. Okay. So what they're saying is, let me just try to do 2 times 2 times 45 is equal to 1/8. So they have created this. Okay, so this, I'm trying to follow along. They're doing it for a slightly different value, but basically they convert that to this, which is 2 times 2 times 45. Right. And then what are they doing over here? Okay. Three. 5 times 3. Okay, so then what they've done is they have separated these out. So 2 to the second. Oh, man. Fuck. This is why teachers are important, kids. This is, if you have a great teacher, hug them. Actually, don't do that. Teachers, it's probably best to not touch anybody at this point because of COVID. But don't even give them a high five. Send them a card in the mail. Just make sure you disinfect it thoroughly before doing so. Or an email. Just send them an email. It says thanks. Okay. So I'm gonna get this. He's moving. He's just kind of like explaining some things very quickly. I just want to try to get enough done so that once I go through the hints, I can see how much I screwed up. Three times 3. Okay, so apparently you need to square both of these, right? So 2 times 2 is 4. So it's square root of 4, which is 2, right? Is that what? Let's see. I'm just gonna follow along. Times 3 times the square root of 13. But what is this number that he has on the left side? I have no idea where that came from. Ugh. Okay. I'm gonna have to get a hint over here. But I think it's gonna be like, I don't know. I'm here to learn. Okay, so I had this totally wrong. Totally, let's factor. There was a lot more. Okay. I didn't complete it. I should have moved up and continued divide. You have to do it until it's not possible to divide. I see. I just didn't do it far enough. So I needed to continue this. So 45, right? Like 45 divides evenly into 3, right? And that becomes 15, which again divides evenly into 3. So you just continue increasing this. So that becomes 3, and that becomes 5, and then it can't divide cleanly into itself. So that's how you end up with 2 times 2 times 3 times 3 times 5, which ends up as 2 to the second, 3 to the second, and then 5. Cool. And then let me see if I can just follow along here. Well, let's just do the hint, and maybe I can get the last one just to follow along. Okay, so then you have square root of 180 is equal to the square root of 2 to the second, 3 to the second, times 5. And so you break these out into their individual square roots. And then 2 times 2 is 4, right? The square root of 4 is 2. And 2 times 2 is, or 3 times 2 is 6, which 3 is the square root of 6. And so then you have these 2 values here. So it's 2 times 3, and that's how you end up with 6 square root of 5. Oh gosh, I think I got it. Oh my goodness. Hey, there you go. Send him a post emoji, Zeg. Okay. Cool. Cool. I think I got it. Okay. Let's try. I'll have another chance to try it. Got it. Okay. So here we go. 63. Let's bust out the board here. So the square root of 63. Bust out the calculator. 63 divided by 2. Can't do that. Right. So 63 divided by 3. 21. So we have 3. 21. Can we divide 21 by 3? Pretty sure we can. It's 7. So 3 is 7. So you can't divide it by 3. Pretty sure 7 is a prime number, right? So you can't be divided by anything but itself in 1. So we have arrived here, which I think that they showed it as something like this, right? 3 times 3 times 7, which breaks out into square root of 3 squared square root 7, which so 3 squared is 6, and so that's 3 7. Is that it? That's not it, is it? That can't be it. There's no way I did this correctly. Oh my god, I did it! Lord Jesus, oh my goodness. Oh, okay. Okay, I got it. I get it. I get it. I get it. Woo! Zeg. My goodness. Okay. Try it again. 108. All right. Bust out the calculator. 108 divided by 2. 54. 2. 54. Divided by 2. It's 27. 2. And 27. So that's the end of the 2's. Because 27 is not going to divide into 2. Right? So let's try 27 divided by 3. That does divide evenly. So that's going to be 3 and 9. And then that is going to also be 3 and 3. So what we're left here is square root of 2 to the second times 3 to the third. And that is going to be 2, right? Because 2 to the second is 4, and so the square root of that is 2. And oh, this one, oh gosh, this is okay. So there's nothing Well, let's just finish it. 9. So it's what? No, not 3 is 9. So it's gonna be 3. So is it 6? Because there's nothing left over. That's not 6, is it? There's no way that's. How does that work? What? No, of course not. What did I do wrong here? I did something wrong. Why 3? Because 9 is the square root of 9 is 3, right? No, oh, it has to be times it's off. Fudge. Okay. Right. Right. So it's not okay. So this is 9. Because 9 is prime. Duh. Duh, duh, duh. Pretend this is a happy face with a nice yellow smile and some teal eyes with some blue hair. Happy little face that was totally meant to be here. La la la. And this is not, that doesn't exist at all. Yeah, but 9 is not prime. What divided to oh shit, Igosat is in here as well. Write it as square root 2 to the oh, got it. Got it. Oh, I screwed. Okay. I misinterpreted. Okay. Okay. Zeg is on the case here. So what I should have written was 2 to the second power times Zeg is on the case, yo. Zeg is on the case. 3 to the second times 3 because there's 3. This 3 is, but you don't just add it. I guess not. This is kind of like, so that's how we're supposed to, so I was supposed to solve it like this, right? So these are each individual, so then this is the square root of 4 times the square root of 6 times 3. Is that what I was supposed to do? So then this becomes 2 times square root of 6 is 3 times 3. So it's 6 times 3. Is that? Uh-oh. Did I screw this up again? Gotta go to the chat. Not times 3. Square root. Oh, I have to square this as well. Hold on. Let me let the kitty out because she's meowing at me. And she's like, let me out. Okay, kitty. Gosh golly, I'm trying to, like, Be less stupid over here. And the kitty is like, yo. Okay. And the 6 is not correct. Whereas 3 times 3. Oh, gosh, you're right. Oh, man. 3 times 3 is 9. Oh, gosh, you're right. So that's supposed to be 9. And, okay, so this is still, I wrote it wrong. But square root of 9 is 3. Right? 1, 2, 3, 4, 5, 6, 79. No, it's not. Oh gosh. I'm having the worst time with numbers this morning. But this is right? At least this part. Let's clear out all this stuff over here. 2 to the second power. 2 times 2 is 4. Right? And then 3 times 3 is 9. And then we have this 3 over here. And so we're doing the square root 3. Right, square root is 3. So so then we need to square all these. So it's 2 times 3 times 3. Is that it? So then this becomes 6 times 3. And then 6 times 3 is what, 18? This feels wrong. Yeah? No? Square root of 3 is... Oh, that has to stay. There is no... Right. There's nothing... Okay. So then this... You right. Okay, so then it becomes this. 6 squared 3. Square root of 108 is... Okay. Oh my goodness, thanks fellas. Yeah, so obviously my multiplication is just really weak, and I forgot that this was, for some reason I just like abandoned the square of this, and also I was adding it into, so this is like the remainder number here doesn't get included into, that's where I got screwed up as well, right? So we're gonna go through all of my mistakes here, right? So I was doing the division by 2, and I was fine up to here, right? 108 divided by 2 is 54. 54 divided by 2 is 27, right? So then that gives us 2 to the second power, and then we were able to divide 27 by 3. So 27 divided by 3 is 9, and then 9 divided by 3 is 3, and where did this 3 come from again though? 27, 3, and 9. The 9 and 3. Only the numbers that appear twice get included. Sometimes even more numbers don't get included. Oh gosh. Maybe we'll see that in the next one. Okay, I have one more. Oh no, it's a summary. I guess I need to try this again. I did not Get 3. Oh, I didn't even get the simplifying square. Oh gosh, I got to do all this again. Okay. All right. Gonna try it. Gonna try it. Okay. So now we have 75. Right? So 75. Oh, shit. Okay. 75. Right. So we'll get the calculator out. And we'll start with 2. 75 divided by 2 does not work. Right? It's 37.5. So we'll bump it up to 3. 75 divided by 3. That's 25. Okay, so we have 3 and 25. Okay. Divided by 3. That doesn't work. That gets us a decimal. What's the point of the exercise? Is to remove all perfect squares from inside of the square root. That's what we're trying to do. We're removing all of the perfect squares. So, so then we'll bump it up to 4, I guess, is the next, right? 25 divided by 4 also doesn't divide cleanly. So then we're going to go to 5, right? 25 divided by 5 is 5. Okay, so we have 5 and 5. So then this becomes the square root of 3 times 5 times 5. Right, which I'm guessing we can... Zeg, you're gonna have to... Can we turn this into this? 3 and then times square root of 5 to the second power. Is that... That's what we do, right? So that we have these 2 here. Which just... I don't think we needed to do that, did we? 3 square root of 3. Okay. I'm a bit flustered here. So this boils down to just 5, right? It's 5 times 5 is 25, and so the square root of 25 is 5. And so it's the square of 3 times the square of 5. Which... Not the square root of 5, just 5. I screwed it up. Oh, yeah, okay, right. So it just becomes... No. How did I screw this up? I don't need this symbol here because it's just 5, right? As you said, it's just 5. So then do I switch it? Does this become 5 squared 3? I don't think you can do that. Like, how does this is our... I don't think that works that way, bro. I'm all out of hints. I can't even get any more hints. You sure? That's it? Is that really it? Wow, okay. It is. Thanks, y'all. Oh my goodness. Oh my gosh. Okay. Cool. Cool. Ah, cool. Okay, next one. Square root of 200. So let's just do it all out again. 2, 0, 0. Right? So that's gonna obviously divide by 2. So we have 2, 100. Right, divided by 2. So it's 2 and 50. Right, divided by 2. So that's 2 and 25. Right, and so now we got to divide the 25 by 3. So that's going to be 3 and 5. So, oh no, it's not. No, I failed. Somebody's screaming at me. Somebody's screaming at me for sure. That's not how that works. Hold on. Let's take a step back. So it's going to have to be 5, right? It's just going to be 5 and 5. It's the same one that we did last time. I don't know why I forgot it already. But it's going to be 5 and 5. Because that's what has left over. Because 25 doesn't divide into 4. Doesn't divide into 3. So it's got to be 5. This is no, it is a different one. It is a different one, but I just meant like the 25 was something that we was a end result at one point. So I should have just known. I should have known this was not going to be 3. Okay, so this is now going to turn into this, which is 2 to the 3rd times 5 to the 2nd, right? And then we'll just break it out into its individual 2 times 2 is 6 times 2 is 12, right? And then times 25, right? You would not write it down. You would only go up to 2. Zeg saying only go up to 2. So I'm curious why you would do it that way, Zeg. So we're going to go ahead and do it that way. So I can learn me some things. So you're saying that you would only go up to 2 squared times 2 times 5, or not 2 squared, 2 to the second power. Don't listen to me. Listen to your teachers, kids. Because if you do it another way, you would get got it. Okay. So this is basically a trick to make sure that you are using simplified numbers, right? That's the trick there, is that we would be looking for the square root of 12. Okay. So basically what we come down to is this, right? 2 square root of 2 times square root of 2 times square root of 25. Is that where we get to? Kind of feel like I'm losing myself here. Huh. This is slightly different, and I feel like I did something wrong again. Oh, it should be square root of 4. You're right. You're okay. Right, square root of, yeah. Gosh, why do I like I'll do something in my head, but then I won't remember to translate it into, so it'll be 4. But I guess what I wanted to do is translate, so that would become 2, right? 2 times square root of 2 times square root of 25. But so then how do we resolve these remaining square roots? That's what I don't understand. Like, how did you... I can get rid of the square root of 25? How do I do that? There's nothing... Oh, of course. Oh, oh, gosh. Thank you, I go sad. Right. Square root. Okay. So that becomes 2. And then that becomes 5. So would I just move these over now and then do 2 times 5 times the square root of 2? Is that where I end up? So then this is 10 times the square root of 2. Is that really it? Can it be? Okay, so with multiplying, I can move it around as much as I want. Right, obviously. Duh. Because 5 times 2 is the same as 2 times 5, right? Oh, we did it! We did it! Okay. On to the next one. Here we go. Square root of 98. Remove all of the perfect squares from inside the square root. So let's start it all over again. 98. hit it with the 2. 98 divided by 2. It's going to be 49. So put the 2 here. 49 here. And I'm pretty sure 49 divided by 2 is going to be sad. It is. It's 24.5. So we got to move up to 3s. 3s now. 49 divided by 3. That's 16.333. So it's not. Is 49 prime? Is it? 49 divided by 4. Pretty sure 49 is, it's a prime number, right? If it ends, I don't know. How do you tell if something is prime? 49 divided by, there's a trick here. No, it's not. It can't be 3 because 49 divided by 3 is 16.3.3.3. So that doesn't divide evenly. So we need some other. So I think it's just 2 and 49, right? I don't think we can break 49 down any further. Oh, is it 7? Oh, you're right. I go sad. You got me. 7. 49 divided by 7. That's going to do it. I just didn't go up high enough. Got it. Got it. Thank you. 7. And then 7. Okay, cool. So we got our numbers here because nothing's going to divide into 7. So then we're going back up here. We'll start all over again. Whoop. And we have 2 times 7 squared. Or 7 to the second power. Which is pretty much this, right? 7 times 7 is 49. Right? So if we do the math, that's 49. And then square root 49 is 7. So it's 2 times 7, which becomes 7 square root of 2. I don't have to write out the 49. I can just write square root of 7, 2. You mean just, yeah, just write this. Huh? You don't have to write out the 49 again. Oh, that makes, yeah. Seven times 2. I don't know why I do that in the, just I guess maybe because it's just that's I'm like doing every single step, I guess, and maybe I don't need to do all that. So is that it? It's not it, is it? I'm gonna try before you all answer. Oh my gosh! Oh my goodness! Because square root and to the power of 2 negate each other. Right. So it makes it kind of silly to write it out that way, doesn't it? Okay, I'll try it the simpler way in this next one. You let me know if I screwed it up. Okay, last one. At least for simplifying. Okay. So we have 175. Right. Let's bust out the handy dandy calculator. 175 divided by 2 is not going to work. Right. So we're going to do 175 divided by 3. And that's not going to work. 175. It's going to be 5. It's not going to divide cleanly into 4. I'm sure. So 175 divided by 5. It's going to be 5 and 35. Is it 35? Do I know what complex numbers are? No, not yet. And 35. Right. And then 35 divided by 5 is 7. So we have 5. We have 7. So we go back up here, start over, and we have 5 to the second times 7. And so this is going to become 5 times square root of 7. Right? No, I guess I can take out the little. Is that it? They're already asking, what is... Oh, you can reply to people in Twitch now? That's very cool. Okay. So, I think that's it. I think it's 5 times square root of 7. Hey! Y'all, thank you so much for helping me along here. I did it. We did it. Oof. Now I just need to do simplify square roots with variables. And that's it for today. 4 questions. We can do... Oh, crap. What the hell is this? What do you mean assume B is positive? Yo, I need to watch a video. I don't know. I have no idea what this even means. Okay, thanks for hanging out, Zeg. I just want to do this before I end the stream. Now there's variables in this. I don't know if you guys can...
This is the same thing as 3 times the principal root of 500. And I'm going to do it a little bit different than I did in the last video, just so, to make it interesting. This is 3 times the principal root of 500 times the principal root of x to the third.
Okay.
And 500, we can rewrite it, because 500 is not a perfect square. We can rewrite 500 as 100 times 5. Or even better, we can rewrite that as 10 squared times 5. 10 squared is the same thing as 100. So we can rewrite this first part over here as 3 times the principal root of 10 squared times 5.
Okay.
Times the principal root of x squared times x. That's the same thing as x to the third. Now, the one thing I'm going to do here, actually, I won't talk about it just yet.
Okay, so they rewrote it. Okay, that's very interesting because they rewrote it. I don't know if y'all can see this. It seems like you can't see it, but they rewrote it the way that Zeg did
This
it.
radical.
So they had they turned the square root of x to the third to the square root of x to the second times x.
Right
Which
here can be
I thought that
rewritten
was
as,
interesting.
so this is going to be 3 times the square root, or the principal root, I should say, of 10 squared times the square root of 5. If we take the square root of the product of two things, it's the same thing as taking the square root of each of them and then taking the product. And so and this over here is going to be times the square root of, or the principal root of x squared times the principal root of x. And the principal root of 10 squared is 10. And then what I said in the last video is that the principal root of x squared is going to be the absolute value of x, just in case x itself is a negative number. And so then if you simplify all of this, you get 3 times 10, which is 30,
What?
times, and I'm just going to switch the order here, times the absolute value of x. And then you have the square root of 5, or the principal root of 5, times the principal root of x. And this is
I
just
have
going to be
no
equal to
clue
the
what he
principal
just
root of
did.
5x.
Legit, like I
Taking the
have
square
no
root of
idea.
something and multiplying that times the square root of something else is the same thing as
What?
just taking the square root of 5x. So all of this simplified down to 30
What
times
is
the absolute
alpha?
value of x
I don't know
times the
what you
principal
mean.
root
I
of
go sad.
5x. And this is what we got in the last video. And the interesting thing here is, if we assume we're only dealing with real numbers, the domain of x right over here, the x's that will make this expression.
Yo, I have no clue what he just did. I need a hint. Unfortunately, I'm not gonna get any credit for this. So factor 80 and find the greatest perfect square. Okay, so they break it down: divided by 2, divided by 2, divided by 2, divided by 2, times 5. How do they get 4? What? Yo, I have no idea what they just did here. Really. IGOSAT has it. I'm gonna get another hint. Factor B12 is a perfect square. Uh, so 80 is equal to 4 squared times 5 times B square. Okay, I'm warming up to this. I'm warming up to it a bit. 2 times 2 times 2 is the square root of 4. But I don't understand how that becomes 4 to the power of 2. Like, aren't you? Oh, I guess all of them need to be squared, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, I get it. Yeah, so 4 to the second power. So they did it backwards, basically. Or I did it backwards in my head. All right. So it's not that much different than the past ones. It's just that the variables screwing me up a bit. But this is very similar to what was done in the past, right? So you have all these values here, and that becomes 4 to the second power times 5, and this is all, we're still looking for the square root of all of this, right? So then they're just tacking on b to the second power to the end of that, and then all of these, these are the individual square roots of those, and then you just move move it around so that it becomes 4 times b squared 5. And now the cat wants to come inside. Damn it, kitty! Can you pick? Cat, like, the cat doesn't just like walk inside, the cat runs inside as if like I was trying to like prevent her from coming in. Meowing at me. Okay, so clearly I screwed this one up, right? But what I can do is just put the answer in there and go to the next one. Basically, 4b square 5. So I'm not going to get any credit for that, which is fine. But here's a similar one. So just to do it all out there again. So we'll forget about the x for now, right? We'll just do 52. So 52 divided by 2 is 26. So it's 2 and 26, right? Divided by 2 is 13. So it's 2 and 13, right? And then 13 is probably a prime number, right? Because you can't divide it by 2. Divided by 3. Pretty sure it's a prime number. Pretty sure. Right. Yeah. B is, in this case, it's x. So now we have this, basically. 2 to the second times square root of 13 times x to the 4th, right? Or the square root of x to the 4th. So 2 times 2 is 4, and then the square of that is 2. Oh gosh. Did you just clip the kitty? I go sad, clip the kitty. Okay. So that's 2 times square root of 13 times square root of x to the 4th. But I don't oh gosh. I don't remember how they resolve that. I mean, does it just is this just the answer? Is it 13 x to the 4th? 2 times 13, 2 times the square root of 13 times x to the 4th, because we can't. What is the square root of x? I have no clue. No, I go sad is helping me out here. What is it, I go sad? I forgot. I wish I had the previous example. Can I go back to the previous example? No. Oh gosh. Oh no. It reset everything. What did I do? Oh, gosh. Oh. Let's try it again. $52 x divided by 2 is 26. 2 and 26. And then that was 2 and 13. And so then over here I had square root 2 to the second power times square root of 13 times x, the square root of x to the fourth, right? And then, so then 2 to the second power is 4, and the square root of that is 2. So it's 2 times square root of 13 times square root of x to the 4th. There's something I'm supposed to do with this x to the 14th, and I don't remember. But there's no way for me to like simplify that, right? 2 times square root of 16th times the square root of the square of x. So doesn't this just end up becoming this? I don't think I can 13 x4, or is there a way to square root of 4? How does that work? The square of 4? So, which, I mean, but that's just like x times x times x times x times. Oh, okay. So then we probably want to simplify that again, right? So that would be, or not simplify, but like break it down like they did before. So this x times x. Oh gosh, I don't remember. I don't remember what they did. The variable's throwing me off. But I don't think we're supposed to leave it as x to the 4th power. But why would it be, why would it just be x? Why would, okay, so Igosat is saying that it's 2. So the answer is 2 times x squared 13. Right? Is that what you're saying? What are you saying, Igosat? Help me out here, buddy. We're in this together now. You and I. He's calculating. He's got his pen and paper out. Okay, so if you're writing it that way, 2 times the square root of x times the square root of 13, wouldn't it be written like 2 times the square root of 13 x? You're not good at math either. Oh man, we're both screwed. We're both screwed, bro. What are we gonna do? All right, I'm just gonna guess. I'm gonna guess. I'm going to take a guess. 2 times square root of 13 x 4. It's not right. How do I get help? Okay, so here we go. We did the factoring. So I did that right. Oh, that's what you were talking about. Oh, you were right. You were right. So that's what it was. So it was x2. Got it. So basically, I'm not sure how to phrase it, but I'm pretty sure I know what I did wrong. And I think you phrased it correctly. Yeah, the square root of x. Okay. Well, I just really just try again. Try again. Try again. Let me just try to make sure that I understand this. So I kind of feel like what happened here. So just as we did before, right? Like you break it down and you have, right, x. So that's x times x times x times x, right? X to the 4th power. And then as Zeg showed us before, like you want to have that in powers of 2, right? So then this becomes x2 times, oh gosh, where's Zeg when you need him? I'm just gonna have to try another one. I'm just gonna have to give it another go. I'm failing to understand what's happening here. Find the greatest perfect square in x to the power of 4. So x to the power of 4, the greatest perfect square. I guess the greatest perfect square is x squared to the power of 2 here. How did they do that? I mean, I guess that makes sense. X squared is this is the same thing as x times x, right? X times x times x times x, right? That's basically what they're doing, but they're finding the greatest perfect square of this, and it's just like my brain is just melting because there's a variable in here. Okay. All right. So, but I think the trick is just kind of what Zeg was talking about, which is to take that. So that's x squared. But wouldn't this be x squared as well? I don't know. I don't know. I need to turn this into a big face. Let's just try to get to the next one. And try again. Try again. 2x to the second to x to the second and square 13. 13. Okay. Well, this is another opportunity I don't know if I'm going to get through this lesson, to be honest with you. For some reason, the variable stuff is throwing me off really hard. So V 56. Oh, shoot. V 56. Start with that. Clear it. 56 divided by 2. It's 28. So it's 2 and 28. Right. Divided by 2. It's 14. So it's 2 and 14. Divided by 2 is 7. So 2 and 7. So what we have now is 2 to the third times 7 z times z7. So once again, is math and English hard? Is that so x to the 4 is x to the 2 times x to the 2. Right. Okay. So then I need to figure out this whole, which is just to simplify it. So 2 times 3 is 6. So the square root of 2 to the third power is 3, right? Because 2 times, no, wait, what am I doing here? That's 2 to the third, 2 times 2 is 4, times 3 is 12. Um, it's 8. 2 to the third is, but 2 times 2 is times 2 is 8. Right. So it's square root of 8 times square root of 7 times square root of z to the 7th. So basically what we have now is 3. Yeah. How did I screw this up? Okay, so z becomes z squared 2, but to what? I mean, how do they convert that to? Oh, I'm about to just Google something else to see. Yeah, now we have to do something with z to the 7th. And I'm not entirely sure how they sorted that out. So z to the 7th which is z times z times z times z times z times z, blah, blah, blah. Don't need to write the whole thing out. But I think we want to break it down to z squared to some exponent. Would it be z squared times what's left over? Or z squared raised to the fifth power? Oh right, yeah. We need to do we need to do the 8 times 7 as well to get the to get our result of that. So as you said, square root of 56. So we have that. Square root of 56. And then we're trying to figure out the square root of z to the 7th power. I have no clue. I have no idea, yo. We're screwed. We're just straight up screwed here. And I have no clue how to get out of it. What if I just Google this? Just Google. Simplifying square roots with variables. Okay, so here's an example. It's very, very simple example. 45 square root of 45 times x to the second is written out to 3 times 3 times 5 times x. Right. Right factors outside of the sign. So that's 3 times, I can see how where using the x as the multiplier becomes very ridiculous here. But this one's not a great example because it goes back to x squared. It can be z. Agoside is saying it can be z 6 plus 1. I'm not sure. I'm gonna be honest with you, bro. I'm not sure. There's something here. There's a simple mechanic here that I'm just not understanding. I should have just started from the beginning. Why did I go straight to algebra? Clearly screwing up my life here. Thus, notice our assumption that x is a non-negative real number is essential. Both make sense for x is less than 0, but they're not equal in this case. Right? I'm just gonna have to look at the answer again. Like I can keep guessing. I would like to know. So how do they do? Because they had 2 before. Factor 56 to find the greatest perfect square. Okay, so yeah, we can figure that out. 56, 2 times 2 times 2 to 7th equal to 2 squared times 14. Oh, so that's really interesting how they, and this just goes back to what Zeg said, where he keeps it as 2 to the second power, and then they just do the multiplication here. So it's 2 to the second power times 14. Find the greatest perfect square in z to the 7th. So this is where I'm really struggling. What? Z to the third power to the second power times Z. We're not idiots, I go sad. We just have not practiced this. Once you practice these things enough and you learn all of the different configurations and stuff, then you start to notice them. Maybe we're idiots. I don't know. But we can still try. Idiots can still try to learn stuff. It's entirely possible. So, 2 to the 7th power is equal to, or Z to the 7th power is equal to Z to the 3rd power raised to the 2nd. Okay. Oh, I think maybe I have an idea. Do you just divide it by 2? So, okay, so here's how I'm reading this now, right? Like, so it's Z to the 3rd, right? Which raised to the 2nd power, so that's kind of like 6. And then it's times Z, so that's where the 7th one comes in. So it's taking this. I guess I just don't understand what greatest perfect square means, and that's why this is like hard for me to break it down. But if I look at this, what I'm kind of seeing is that, okay, we had 7 here, right? So 7, you take 1 from this 7, and that's this Z. That's this trailing Z, right? And then you have this Z to the 3rd, right? Raised to the 2nd power. So that's kind of like, so if I were to just write this out, so it's Z times Z times Z, right? That's Z to the 3rd power. And then you're raising that to the 2nd power. So you're doing that twice, right? So that becomes, so we're this is a continuation, right? So then it becomes Z times Z times Z, but we still have 1 left over, right? And so that's where the last Z comes in. So this is 1, 2, 3, 4, 5, 6, 7. There's our 7 Z's raised to the 7th power, but we've simplified it. Well, I don't know if I would call this simpler. But this is the greatest perfect square within that number configuration, it seems. So, okay, so I kind of got that. I don't know how to arrive at that quickly though. Like, I don't know how they figured that. Do they do it just based off of do you know what I'm saying? Like, it, like that makes sense. Like, this makes sense to me that through Z to the 3rd, and then raise that to the 2nd, and then times Z is equal to Z. Like, this is, I kind of get that, but how they arrived at that, it's not clear to me. Right, it is exactly. I go sad. That's exactly what it is. These are equivalent, but how they turned this into this, it doesn't make any sense. Like, they don't show any of the, like, what they did to arrive at that. Like, that doesn't so that's what, excuse me, that's what I'm trying to, like, try and really understand here is, like, how do you arrive at the greatest perfect square? for a variable raised to an exponent. Like, we're just going to Google it. Find greatest perfect square of variable. Simplifying radicals. Is that what I want? Okay, here's another example, but it's with x2. I want a greater number than that, but not with like multiple variables in there, because that's just confusing me. Right, but like how do you just like count up? Like is that, well, let's just get the other hint over here and finish this one. Okay. So let's say that I wasn't stupid and we figured that out and we arrived at this new equation, not equation, but this new square root. Factor 56 and find the greatest perfect square. So 56z7 is equal to 2 to the second power times 14 times z to the third raised to the second power times z, square root of z. So then they separate everything that needs to be multiplied out. And they squared this. Yeah, so this is interesting. This is really interesting because they're squaring this, but it's I guess just the variable is screwing me up somehow. Because obviously the square root of something times itself is going to be that thing, right? So that's what's happening here. So this is 2 to the third power raised to the second power, and then we're getting the square of that, which is obviously just going to be 2 to the third, and then that is multiplied by the leftover z. So then we move everything over, and then you have 2 times z to the third times the square of 14 times z. So it's like, I get it. I get this, but how they are, this is where I need to figure this out. I think I'm just going to do some learning on that. I'm going to spend a bit more time trying to understand that side better. And then I'm going to come back and I'm going to finish these exercises because clearly it's just, I'm missing something that's probably really simple here just because we've moved to variables. So in short, I'm a bit of a dummy. But I'm going to, we're going to come back here. We're going to come back. And where did I get to? I got to simplifying square roots with variables. That is where I need to do a bit more research, do a bit more learning, and just like probably practice those for a little bit. You know, practice like that one specific thing, simplifying square roots with variables. So that's what I'm going to do. I'm going to learn that. And then I'm going to come back at it Zeg, I go sad. Did I go to uni? I did. I tried. I dropped out twice. First time because of money, and second time because I was like, whew, this is not going well. So as you can see, I probably struggled quite a bit in those classes as well. But that's going to be it for the stream today. Stay in school, kids. Stay in school, or else you're going to be struggling to simplify square roots of variables. Catch you later, broski.